Hello everyone and welcome back. In this new lesson we are going to introduce some of the problems that asynchronous operations performed by Angular components can create when writing tests for those components. So in this case we have here a simple component with a tab container, and as we can see, even though we are running here change detection after simulating a user click here on the advanced tab button, we still can't get the advanced courses here reflected in the DOM and our test is failing. So what is going on here? What's going on is that the tab container component that we are using here is performing an asynchronous operation while switching tabs. If you notice, there is a small animation here whenever we switch tabs. This animation is produced by using the browser API request animation frame. This is one of the many browser asynchronous APIs. Another example of an asynchronous browser operation is setTimeout. Imagine that this component here was calling setTimeout before switching tabs. That would make the component asynchronous as well. Another example of an asynchronous API would be to call setInterval in order to execute a callback at regular intervals. Another example of a browser asynchronous API would be, for example, to do an HTTP request. We could do that, for example, using the browser built-in fetch API. This API, which is a promise-based API, is also asynchronous. The HTTP request might take several seconds to execute on the backend before retrieving the results back in the browser, which will trigger the execution of a callback. So going back here to our test, what is exactly going on here? Why is this test failing? Well, the problem is that after triggering here this click, the tab container component that we are using to implement our home component, which is this material tab group component, this component is internally using a call to request animation frame. So going here to the documentation of this browser API, this is used for animations. We simply pass it a callback and the browser is going to call our callback after 16 milliseconds typically in order to ensure a fluid animation, and this function is guaranteed to be called before the next browser repaint. So it's a built-in native browser mechanism which is asynchronous, like a call to the backend using an HTTP request, and that helps us to build smooth animations. Going back here to our test, what does this imply? It means that the changes here to the DOM are not going to be applied here immediately after calling here Angular change detection. So here at this point in our test, even though we have clicked the tab and even though we have asked Angular to apply the latest changes to the DOM, the component will not apply those changes immediately synchronously to the DOM. The container is going to first wait for the callback passed to request animation frame to complete before applying the changes to the DOM. So this means that we cannot write here our assertions synchronously right after triggering Angular change detection like we are used to so far in this course. So how do we fix this? Well, because we know that the changes are going to be eventually applied to the DOM asynchronously, one way would be to simply call here setTimeout. So we are going to pass in here a callback to setTimeout, and let's say that we would wait here for 500 milliseconds. So this would give enough time for the animation frame to complete, which means that if we pass in here our assertions inside the body of the setTimeout, then we would be able to run them here. So let's see if this would work. We are going to run again our test, and if we now switch here to the test results, we are going to see that the test is passing successfully. But what is happening here is actually very deceiving. If we now open the console, we are going to notice here an error message. Expect was used when there was no current spec. This could be caused by an asynchronous test. So what is going on here? What happened now in this new form of the test was that the test runner exited this block, and because it did not find any assertions during the execution of this block here, it considered the test as being passed and it never executed these assertions here before considering the test to be completed and passing. Then later on, after 500 milliseconds, while there were no longer any tests being run, only then were these assertions executed. But this means that the assertions were executed long before the test has been considered completed. So this is not what we want. We would like the test runner to somehow wait for these assertions to be called before considering the test completed and moving on to the other test. So this is an example of an asynchronous test. Jasmine gives us support for asynchronous tests. We can receive here via our test specification function a parameter called done. So this is a Jasmine specific callback that we can annotate here with the done function type. So this function is supposed to be called whenever our synchronous test is completed. This means that Jasmine, whenever it executes this test block here, will not immediately consider the test finished when the block exits. Instead, Jasmine will only consider the test completed and move on to the other tests of the test suite only when the done callback is called. So let's see what would happen if we would run this test as it is without any further changes. Remember, the use of done here as an argument has already given the indication to Jasmine that this is an asynchronous test. If we now run this test without any further modifications, we still get here a failing test, but this time around we get a different error message. So as we can see, the test is failing, but this time around because the async callback, which is the done callback, was not invoked within the default timeout, and the default timeout is currently of 5 seconds. So Jasmine knew that this was an asynchronous test because of the use of the done callback, and Jasmine did not receive any indication that the test was completed in a time frame of 5 seconds, so then it considered the test as failing. So how can we mark the test as completed? We are going to simply here, after all the assertions have been executed, we are going to call done. So this will give to Jasmine the indication that the test is completed and that all the assertions have been executed. So if we now run this new version of the test, we are going to see that this time around the test is considered as completed and passing, but also we don't get here any error in the console unlike before. So we have the guarantee that indeed these 3 assertions were executed before the test was considered completed. So this means that our test is passing and the functionality is tested. We have confirmed that indeed clicking here on the advanced button has indeed caused the courses card list to switch to the advanced courses. As we can see, the test is now passing, but this use of setTimeout is really not very convenient. We would instead prefer to keep writing our tests for components that use asynchronous operations in a similar way to what we have done so far. So by specifying here the setup phase of the test, then the execution phase, and then the test assertions sequentially without any nested blocks. So let's see what are the multiple test utilities that Angular provides us for writing asynchronous tests in a more maintainable way.